Okay, welcome to the video for the stock simulation lab, and I've went ahead and created the spreadsheet that I'm going to be asking you to make. So I'll give you a tour of that spreadsheet, and then I'll explain a formula that we haven't used yet that you're going to need to know, and then finally I'll look at how we can estimate the parameters for our normal distribution. Okay, when you open Excel, you'll probably have this home selection on the menu. So what I'm going to do first off is go over to formulas, and let's see, I need to stop trying to enter information into the cell so that these options become available. I'm going to go to calculate options, and I'm going to set that to manual. It's actually already set to manual, but if you haven't done anything with this, it'll be set to automatic. And notice that when I set it to automatic, that means it keeps recalculating my spreadsheet. You might remember earlier that the random numbers get recalculated every single time you do something in Excel. Well, this is annoying when you have as much data as what I have here. So this is 41% done computing. I'm just going to let that get finished computing, and then I'll turn this to manual. Okay, so we're going to find the mean and the standard deviation of the daily rate of return for the stock price, for a stock of your choice. In this case, I've pulled data from McDonald's stock price and found that the closing price for yesterday, which was January 13th, 2011, was 72.67. Okay, this is done, so I'm going to go to calculate options, set that to manual. That way it will not keep recalculating for me anytime I change things. And then what I've done is I've went through and I've simulated the daily stock prices. Now, this isn't actually a simulation of the stock price that you would see if you went onto a financial website. It's a simulation of the value, and the difference here is that I'm incorporating dividends, and if there happens to be a stock split, into this. If you ignore dividends, then it looks like stocks aren't increasing as much as they really are if you think about the dividends. And if I go all the way over, I go to column, column IQ. Okay, and I go to column IQ because I'm at IQ. If I press Shift Control left arrow, that'll take me back. Notice that I have 251 columns here. There was a 251C for the columns, so that's 250 days, not counting this initial day that we found from yesterday's stock price, yesterday's closing price. Okay, so there's a bunch of stock prices here. Each row represents a year, and a year is 250 trading days. That's why I have 251 columns, because the last column would be a year from this first day. And then, how many rows do I have? Well, I started at row 6, I believe, so I went down to row 1005. And that gives me 1,000 simulations for the stock price, daily stock price over the course of a year. Okay, so there's all these stock prices, and again, I've found the mean daily rate of return from from actual data, from 10 years of data. We're going to pull that from Yahoo Finance, and then the standard deviation is pulled from that same data. And then over here, I have counted the number of the 1,000 simulations that resulted in a decrease in the stock value after a year, and a substantial decrease. I'm defining that as a 10% decrease. Is calculating here. If my 1,000 simulations, about 21% of them ended up giving it more than a 10% decrease, and then more than a 10% increase. It actually ended up being almost half of them gave that big of an increase. Okay, now I'm going to discuss how to compute these stock prices. So let's say that my stock price is 72.67, like I have here, and I want to compute the next day's price, as was given in the formula in your lab handout. To compute that price, I take the previous price, 72.67, times 1 plus the daily rate of return. But the daily rate of return is random. right? We don't know what the closing price is going to be tomorrow. There's lots of people that are out there trying to figure out how to know that. But as for right now, there's not a good way to predict that. Okay, so this is going to be a random quantity that we're going to enter. And it's going to be randomly pulled from a normal distribution with this mean and this standard deviation. Okay, now to do that, I'm going to need to use a couple of Excel functions. And the first one I'm going to use is norm inverse. Okay, what this does is it returns the inverse of the normal cumulative distribution for the specified mean and standard deviation. In less technical language, it looks at the normal distribution table, right, which I have right here. It finds the value that you want in the middle, and then it returns the z-score. Okay, it finds the value and it returns the z-score. So let's see how that works. Norm inv, and then I want the probability, and that's the number that we want to enter into the middle here. Well, to get a true distribution, what you want is that these cumulative probabilities, these probabilities that z is less than or equal to that z-score, are uniformly distributed. So I'm just going to pull a uniform random number between 0 and 1. And in Excel, that means that's the rand function. Okay, the mean of my normal distribution is going to be in cell B2. And notice that you will want to put dollar signs before the B and before the 2. And that's to signify that you don't want this to change when you fill it to right or fill it down. Okay. And then the standard deviation is in cell B3, and we'll also want to put dollar signs on that. Okay, I press enter, and that'll give me an error. Let's see. It's correcting my formula. Okay, it's just putting a multiply in there, I believe. Maybe I don't have enough parentheses. No, I think it's just putting a multiply in for me. Okay, thank you for correcting my error, Excel. And there's my next day's stock price. Now I want to show you that that norm in function is really pulling from the table. Let's pull up the table here. And I'm just going to choose some number. How about this? 0.8315. That corresponds to z equals 0.96. Okay. Oh, I forgot my number. What was it? 0.96. 0.8315. So I'm going to enter 0.8315 for the probability. And then the z-score gives the value of the normal distribution if the mean is 0 and the standard deviation is 1. For the normal distribution, so we'll put in a mean of 0 and a standard deviation 1, and I should get back to 0.96, and sure enough I do. Okay, so this norm in function is finding your probability in this table and outputting the z-score. Well, actually it doesn't output the z-score, it outputs the value for the normal random variable because you give it to the standard deviation and the mean. Okay, so the last thing I'm going to do here is describe how to, or show you how to get this mean rate of return as well as the standard deviation of that rate of return. Okay, so I'm going to pull up internet browser here. Okay, I'm going to go to www.yahoo.com, and we want to go to Yahoo Finance. Okay. And I used McDonald's, so I typed in McDonald's here, and let's see, I don't need the apostrophe. Alright, there's my McDonald's. So I'm going to click on McDonald's, and I'm wanting the historical prices. So over here, I've got a link for historical prices. We want the last 10 years prices. So let's see, this is January 14th. Let's change that to January 14th. It'll be whatever date you do this on that you'll be entering here. And 10 years ago was 2001. So I'll enter in 2001 there, so get prices. Notice daily was already selected. And if I scroll down, I can download the spreadsheet. Okay, I click on download spreadsheet. You might have to change the program. I suggest you open it in Microsoft Excel. Okay, and here's my information. Now this date column, the column isn't quite wide enough. You want to widen it a little bit so that it'll show all of the dates here. So we have date, we have opening price, high price, low price, closing price, volume, that's how many shares were bought or sold, and then adjusted close. And it's this adjusted close is the only thing that we're going to be working with. And the adjusted close, notice at the very top, and the top several rows, it matches the close. But if we go down a little ways in the spreadsheet, okay, the adjusted close no longer matches the close. And that's because adjusted close is incorporating in dividends and something called a stock split, so that we can compare this closing rate to today's rate, right? Because even if the actual stock price was the same, if we got a dividend, we're better off than we were previously. And we want to incorporate that in by doing the adjusted close. Okay, so to get the rate of return, let's see, what was our formula? Our formula was P1, the closing price on this day, is P0, the closing price on the previous day, times 1 plus R. Okay. So to get R, what do I want to do? Well, I would take P1, the closing price on the current day, divide by P0, the closing price on the previous day, and then subtract 1. So that's what we're going to do to get R. We got equals, the closing price on this day is in column G, cell 2, or row 2. Okay, and we're going to divide by column G, row 3. And then we subtract 1. So that gives me the rate of return for that day. Now if I go all the way down, I'm going to press Shift, Control, hold those down, and press End. Okay, that takes me down. I'm just going to use this one column. Fill down. That'll fill my formula all the way down for me. Okay, and it is not recalculating, and the reason that it's not recalculating is that I told it not to. So we need to do automatic recalculating here and let it calculate. Okay, so now I've got all that information, and it says it's still calculating, and that's probably because it's working with my other spreadsheet. But these are all my daily rates of return. And all that's left to do is to compute the mean and the standard deviation of those rates of return. So notice that we go down to row 2515. 2516 doesn't have a value, and that's because that was the first day of our information. So we don't have a previous adjusted closing value. So I'm going to go down to row 2515 when I compute the standard deviation and the mean. I'll press the up arrow key to get back up to the top. Okay, so the mean R is just the average. It's the average from I2 to I2515. And the standard deviation is the standard deviation. We'll do equals STDEV from I2 to what do I say, 2515, I believe. Okay, so that gave us 3 zeros and then a 519 for the mean. And if I look back to my other spreadsheet, that's exactly what I have here. Then I have the 0.016119, which I believe is also what I had there. Yep. Okay, so you're going to submit the spreadsheet. Make sure that you have all the formulas in here. Do not paste them as values. I want to be able to see what your formulas are, how you're calculating things. And then I don't care if you turn the calculation on or off. I can manipulate that very easily. So again, please let me know if you have questions with this lab, and good luck.